Alright, the goal of today is get better with factoring when they're all mixed together. So I want you to make sure that you have out the factoring flowchart as well as a pencil and a calculator. I'll have you pause the video until you have those things ready. Alright, we're going to go over kind of a review of what we're looking for here. Remember, when we're just factoring, the first step we're going to look for is greatest common factor, because a greatest common factor could happen even with some of these other methods that we talked about. So we're looking for that first. Remember, it could be a number or a variable. Okay, so look for both. And then if we have two terms, we're looking for a difference of squares. Okay, it's going to look something like we have something squared minus, I'm just going to pick 4 because that's a perfect square. So both of those can be factored into their square roots, and the opposite signs make the middle terms go away. We've got on the 3 side term 3 options for us. Okay, so what we're looking for is trying to potentially recognize shortcuts. And so perfect square trinomial is a shortcut when numbers are really big. So if you see perfect squares again, but they're bigger, like 64 or 121, that's something we want to recognize a perfect square trinomial for. If they're smaller, we can get away with using one of the other methods, and it may be, honestly, less time. Okay, easily factorable, remember, is something that has just an x and an x in it. So coming up with maybe -1 and +2 from the original x squared plus x minus 2. Okay, we can just say the factors of -2 that add to be 1 are +2 and -1, and they plop right in there. Okay, then frowny face is when we're going to use the box, and that's going to be any time we have an example after we've taken a GCF out, and after we've decided they're not perfect squares, we have some number still in front of our x squared. So that's the key, where we have to use the box. Now I say have to because any of these 3 that I just talked about can use the box method, and you're okay to do that. Okay, so we're going to just go through and practice some of these things again, going through this list. So first up, greatest common factor. These 3 terms, there is no number in all 3 that goes in, there's no number that goes into all 3, and the x doesn't show up in the last one. Okay, there are 3 terms, so we're over here, and this is going to be an easy factorable because there's no number in front. So when that's the case, we can skip to our first set of parentheses times their second, a binomial times a binomial, where the first part is x times x. Then we're looking for the factors of 12 that add to be 7. Remember, if you're someone who this is the hardest part of factoring, just take the time to write them out, because it will take less time to write them out than it will be to sit there thinking and getting frustrated. Okay, so out of these ones, the 3 and the 4 are the winners to get 7. And everything's positive here, so we're going to say +3 and +4. That's our factored form. This was considered easy factoring. Okay. Over this next one, we've only got 2 terms. We're still going to look for a GCF first. Looks like both of these are even, so at least the number 2 goes in. But hopefully you realize that 4 goes in evenly. So I've got 4 that I can factor out. 4 times x squared gets us to 4x squared, and 4 times -9 gets us to -36. Okay, now with this 2 terms, the only other thing we can do is difference of squares, and this in fact is a difference of squares because I've got a first term that's a perfect square, second term that's a perfect square, and a mice in between. So this is going to still be pretty easy to set up, but we're using the square roots to pick our first terms and our last terms. So square root of x squared is x, that goes first for both, and the square root of 9 is 3. That goes first, or second for both. And then in order to multiply to be a negative, I need 1 positive, 1 negative. Okay? With that, we really had 2 things going on, GCF and a difference of squares. Next one here, we're looking for GCF first. We got three terms, the 5, the 18, and 9. They do not have anything in common, and the 5 is not a perfect square. And because that 5 is in front instead of a 1, we don't see a number in front at all, this has to be a box one. So we practiced some of these last time. Hopefully we're getting good at the process. Again, finding the factors is usually the tricky part. We're putting 5x squared in the 9. I like to circle these to help me with this part here. We're going to multiply them. There's our frowning face that's happening. 5 times 9 is 45. Okay, and then we're trying to get to negative 18. So once again, for the sake of the video here, I'm going to go ahead and list all of them. 1 times 45. 2 doesn't go in evenly. 3 times 15. 4 doesn't go in evenly. 5 times 9. 6 doesn't go in evenly. 7 doesn't go in evenly. 8 doesn't go in evenly, so that's all of them. Of these ones, we're trying to get to 18. So these ones will work if we make sure we can get to a negative 18. So if I put a negative on both of these, that gets me the negative 18, but also multiplying them together, negative times negative, will get me to the positive, so it works out. So with this, just a reminder for your notes, when we see a positive here, our factors have to be the same sign. So I'm going to write the negative 15x here and the negative 3x here. Doesn't matter the order technically. And GCF my way around. So first row, I've got a factor of 5x that I can pull out. And second row, I need to factor out a negative. Okay, so that's a negative 3 that can go into both. Remember, you can also use kind of the formatting of the box to help you. 5x times x gets me to x squared. 5x times negative 3 gets me to negative 15x. Okay, so I have two factors here, 5x minus 3 and x minus 3. We're going to check our work here. Does 5x times x get us to the first term? And then we want to see, does the second term times the second term get us to that last one? And it works out for us. This one was frowny face factoring, or you can write box. Either one for me. Okay. Looking at this next one here, same type of process. We're always going to look for that greatest common factor first. We've got 9, 48, and 64. Looks like there's not a number that goes into all three of those. Okay. When we're looking at the next thing, PST, perfect square trinomial, I do have some perfect squares here. Okay, so we're going to test it. Over to the side somewhere, we're going to do square root of 9x squared. That's 3x. Square root of 64 gives me 8. And when I multiply these together and then double it, I should get 48. Okay, so when I take 3 times 8, that's 24. 24 times 2 is 48. You do have to check that middle term. You had a homework assignment the other day that looked like it might be a perfect square trinomial, but it ended up being prime because that middle term didn't match. Okay, so be careful on that. This one does in fact match, which means I can skip to our shortcut factoring pattern, which says we're going to use those square roots. The 3x and the 3x get me to the 9x squared. The 8 and the 8 get me to 64, but because I need a negative 48 to happen in the middle, they both have to be negative. Okay? If it helps convince you that this actually works, from what we did in Chapter 8, you can work your factors backwards. Okay, we already checked the first and the last, but here's the negative 24x and the negative 24x that are creating that middle term. Okay, so this one was a perfect square trinomial. Alright, what I'm going to have you do is pause the video, and I want you to do problems 5 through 8, so the rest of the regular factoring problems. Okay, you can work with people around you, but I want you to take 10 minutes to solve those problems, Okay, stay quiet if you get done early while other people are working. Okay, and then in 10 minutes, hopefully everybody will have a chance to at least look at all of them, but hopefully get them taken care of using our examples we've covered so far, and then I will go over the answers. Okay, so pause the video and try that now. Alright, looking at number 10, hopefully you saw easy factoring. Because there is no number in front, I can skip to x times x, and I need the factors of negative 24 that add to be negative 5, so that's negative 8 times a positive 3. Okay. Over here on this one, it ended up being box factoring. Okay. Setting up the box for this one, we have 3x squared and negative 20. So for this one, we're looking at the factors of negative 60 that add to be 11. Okay, and anytime this number on the top is bigger, it can help to write out your factors. 1 and 60, 2 and 30, 3 and 10, 4 and 15, 5 and 12, 6 and 10. Okay, that's all of them. And it was the 4 and 15 that worked for us as long as we adjust it to be a negative 4. That takes care of the negative being 60. Excuse me, the 60 being negative because that has to be opposite signs. And when they're added together, we result in a positive. So we've got 15x here and minus 4x. Factoring around, we have 3x, negative 4, x and 5, our final factored form being 3x minus 4 and x plus 5. Remember, these can be flipped around in any order. You just have to make sure your first times your first gives you 3x squared, and your second times your second gives you negative 20. On number 7, you could have either said easy or perfect square trinomial. For this one, I would skip to easy, even though it technically is a perfect square trinomial, because it's easy to find those factors that work out for us with x times x giving us the x squared. So we've got x minus 6 twice. Okay. Don't forget, problems like these, when you're solving them, only result in one answer, and you'll call that a double root. This last one was a simple GCF problem. We didn't see one of those together, but there was an x in both terms along with the 3, so we can factor that out, leaving us with 2x plus 3. And because nothing's squared, that is the only thing we're doing for that one. Okay? We're going to go ahead and keep going with the same process. One extra step, we want to make sure we can solve when we have an equation. So first step for this, it just adds in, make sure we have equals 0 first. Okay, so that's the thing we got to check for before we move on to our flowchart. So here, we have equals 0. Next thing we're doing is looking for a GCF. This one is just like that last one we were doing. There are only 2 terms, but there's an x in both terms. So that's something we can factor out. We can also factor out a 2, since these are both even. So we're going to do 2x. And then go ahead and write the rest equals 0. 2x times x gets me to that 2x squared. And 2x times a negative 4 gets me to that 8x. So I have 2 pieces. That could be 0. I'm going to set them equal to 0. And we've been practicing solving without the steps. I'm going to go ahead and write them here. Divide by 2 gives me my first answer of 0. Adding 4 gives me my second answer of 4. So this was another just GCF problem. Okay. Number 10, we've got it equal to 0, so that's good. Not a GCF on this one, since there's no number in front, and there's not an x in all 3 terms. Okay, so this one, because of that just being a plain Jane x squared, that's going to be an easy factor. And we're skipping to x times x. And don't forget that equals 0 for these ones. We're looking at the factors of 25 that add to be negative 10. So for this one, again, you can write them out if you need to. But because that was a 25, this one actually ended up being a perfect square trinomial because -5 and -5 works for these ones. Okay, so this is what I was talking about. When you write out these equations, if you write them out, they both look exactly the same, which means they solve exactly the same, both resulting in x equals 5. It's silly to write x equals 5 twice, so we just put the number 5 and we say double root. Okay. Fundamental theorem of algebra says that if our power is squared, we have to have two answers, so it's important that you write that double root for me. Alright, you're going to pause the video and take care of number 11 and 12. Come back in about 5 minutes and we'll check those. Alright, number 11 had a GCF first. The x squared came out and then the 9 was a result here. Because there are two terms, we're looking for a difference of squares, and it was. The square root of x squared is x, and the square root of 9 is 3. Multiplying those together, excuse me, I'm trying to do a perfect square trinomial there. Not multiplying those together, but realizing that when we put x here, 3 here, 3 here, trying to get to a -9, we have one positive, one negative. Those middle terms go away. Okay, so this one's just x and 3 here. With that in mind, we're going to have two different answers. The 5 equals 0 doesn't mean anything for us, but the x plus 3 equals 0 and the x minus 3 equals 0 do. We're going to subtract 3 for this one, giving -3, and add 3 for this one, giving +3. Okay, so this one was a GCF with a difference of squares. Okay. This last one over here, because we've got a little 1 here, there is no GCF in these three terms, and this, unfortunately, is going to be our longest step with the box. Okay, so here, setting this up, 6x squared, -12. We want to look at the factors of -72 that add to be 1. Okay, hopefully this one was a little bit easier with the 72 being 1 away from each other. So this was 9 times 8 is 72, and I need a negative with the 8 to make this work. So 9x here, -8x here, and I'm GCFing my way around to get 3x times 2x there, 3x times 3, and then 2x times -4. Okay, if it helps doing it that way instead of GCF. Might be faster in some cases. So I've got 3x minus 4 and 2x plus 3. Don't forget your equal 0 for factored form. Okay, each of these we're setting equal to 0. Okay, hopefully you got 4 over 3. Opposite of this thing, divide by that thing. Same thing over here, opposite of this, because we're going to subtract it over. And then we have to divide by 2 to get our last two answers. Okay, your review 1 is your homework for this, and it should be set up pretty similar. Feel free to check your answers as you go.